At the Integrated Publication and Information Systems Institute in Darmstadt, Germany, a 3D visual user interface for information retrieval in huge text databases has been developed. The user interface was designed to provide naive users of retrieval systems with the powerful functionality of such systems without their having any knowledge about a formal retrieval language. Furthermore, the system visualizes content areas of the search database to provide the user with intuitive control over his search dialogue. The system, called LibrWorld, will be introduced in the following video.
LibrWorld provides 3 interactive visualization tools to the user. The tools offer different functionalities during a search for certain documents. The 3 visual tools are a navigation cone, a relevance sphere, and a database symbol. They appear symbolized by 3D icons at the start of each LibrWorld session. In the following, we will report about selected situations extracted from an example retrieval session. At its current state, the LibrWorld prototype accesses a database containing about 800 abstracts describing research projects. In the demonstration case, the user aims at finding research projects investigating alternative ways for efficiently heating houses. After initiating a search by entering a first keyword, heat, the user activates the navigation cone. It displays all documents containing the keyword heat on a red document level. After reading the document titles, the user decides to follow on the document entitled Courtyard Passive Solar Houses. He selects the document to become the current item and requests to unfold its term sublevel. The resulting term view, displayed as a blue sublevel, is browsed. It contains the term solar, which the user selects to continue his search with. On the next red document level, the user selects the item Solar Architecture in Europe after browsing the titles of all displayed documents. He expands its blue term subview and browses the displayed terms. The resulting view contains only a small number of documents. They are all colored orange instead of red. The user recognizes that the documents are displayed orange because they are bearing hidden paths. This means they were already found in an earlier view. As all documents bear such hidden paths, it does not make sense to continue on one of these documents into an already searched area. The user decides to continue with the thermal keyword, which he still remembers. As thermal is currently somewhere on the back side and the user doesn't know its exact position, he requests to add a new keyword and enters the string thermal. The system realizes that the item thermal was already explored and an animation moves the user towards the correct view position. It rotates the appropriate keyword label to the front where the user requests to unfold its document sublevel. The resulting document view contains quite a lot of items and only a few of them are already known. As the new document titles do all look a bit misleading, the user decides to stop his exploration and to start identifying the result kernel of his search. The navigation cones are closed and the relevance sphere is activated. The system has transferred the retrieved documents into the sphere's center where they appear as a cluster of little book symbols. The terms selected in the navigation cones are displayed as small blue spheres, equally distributed on the surface of the relevant sphere. After manipulating the relevant sphere's orientation and the heat symbol into a better display position, the user starts his clustering activities. He clusters the house and the solar terms on the surface of the relevant sphere. One can now recognize a small subgroup of documents in the center which follow the movements of their keyword spheres, while two other streams of documents remain attracted by heat and thermal. The user wants to isolate the influenced group from the other documents. He increases the size of solar and house to increase their attraction. The documents react and the cluster starts moving towards the two keywords on the surface. To enforce this effect, the user reduces the document density in the sphere and the cluster becomes fully isolated. The outmost document of the isolated cluster has left the sphere while the user reduced the document density. It is displayed as an open book because the system regards it by default as the most relevant result. The user activates the database icon and the open document's textual content is displayed in detail on the back wall of a room. By opening other books of the isolated cluster, the user recognizes that most of them meet his initial interests exactly. The result kernel of his information search is determined. As the three tools work complementarily, the libosphere can now be deactivated and the selected document will remain in the room. The room works also with the navigation cones. This enables the user to inspect documents in detail at all times during his search for information.
This demonstration has presented the usefulness of visualization systems within information retrieval applications. Especially non-retrieval expert users have been provided with the functionality of a powerful probabilistic retrieval engine. By applying spatial metaphors, the cognitive load for orientation and navigation in the content space of the search database has been reduced. A visual clustering of information in terms of specific information attributes was achieved by applying a metaphor of attraction. This is only a first step, however, towards intuitive explorations of databases by means of virtual environments.